Next up, our presenter joins us from BIOIONIX. This company provides a technology that eliminates harmful pathogens and disease from our food supply, sustainable with no harmful chemicals. It was originally founded by a NASA grant for space shuttle water reuse. Please welcome to the stage with a warm round of applause BIOIONIX VP of Sales, Carl Jensen.
Thank you. Thank you. Hear me okay? We're good? All right, thank you. We spoke last year at this. I apologize if anybody's here from last year and this is going to be repetitive. I'm going to try to make sure it's not a little bit, change a few things up. As we were introduced, we are a company that was founded actually on a NASA grant. Kind of some collaboration between the University of Wisconsin and some engineers. The task was to be able to find a way to be able to reuse water in space. That would be for the International Space Station, space shuttles, et cetera. The really bright people that looked at this failed to advance the process with NASA, but what they did is they uncovered some really incredible technologies to be able to do some really amazing things from a standpoint of disinfection. Fortunately, we're based out of Madison, Wisconsin. At the time, there was a little hot dog plant there called Oscar Mayer, and we were able to essentially cooperate with them to be able to establish this technology and bring it into the food world. Fortunately, we live in Wisconsin. We do have, again, a lot of RTE meats. We also have a lot of cheese, very large cheese industry. In case you lived on Mars, you would know that Wisconsin's known for its cheese. And so folks in that area saw what we were doing, what we were able to do with this electrochemical process, needing water and salt to be able to do some pretty amazing things. And basically the technology began to grow and find new ways to be used. Currently, we're treating in a day like today, how many million gallons of brine around the world in the cheese industry, 5 continents that we have systems on, hundreds of millions of gallons that we're processing and putting through in a day, being able to reuse that water, requiring that it is not dumped, and then also being able to provide a high level of disinfection. Briefly, that's what we do. We work we're a food safety company. We use a technology that is able to take salt and water, produce a disinfectant. We can then use that disinfectant in a number of ways. And aside from disinfecting, I think the thing that I'm most excited about is our sustainability package, where we're able to find ways to reuse water. Water is often used as for its thermal purposes, be it heating or cooling. And we're able to essentially recycle and recondition that water so it can be reused. Very exciting platform. We do have an FCN 2198. You can look it up if you're really bored. I'm hoping I don't bore you that much, but this is chemistry and it is after dinner and you guys are probably starting to digest food, get sleepy. So if I raise my voice, that's probably why. FCN 2198 does define what our roles are as far as food contact treatment, so actually on food. We're very well established with the USDA FSIS for folks in the meat industry. And then we are an EPA-approved site because essentially what we do is we sell a generator that produces, I'm not crazy about the way the EPA defines it, but it's a pesticide. But we'll go more into that. So we do have an EPA-registered facility to be able to sell you the generator. The generator is in the middle there. Around that circle is kind of our cycle of all of the different things that we can do. Water reconditioning, I mentioned that. Animal welfare, our owners. The owner of our company, the principal owner, came from the animal-centered environment business, so he's got a passion for dairy, living in Wisconsin. And we know this technology can be used pre-harvest because of its safety and its massive scale and availability that we can produce. We are a food safety company. I have termed the term CIO. Everybody knows what CIP, clean in place, COP, clean out of place. We do a thing called CIO. We're actually able to clean in process while production of food is occurring, which is a very unique thing, to be able to disinfect processed water and then also make that processed water a vehicle of disinfectant. Very unique thing. We're doing it with water and salt. To be able to reuse water, you need to accomplish essentially 3 things. This is defined by USDA. You need to have a microbial elimination. You need to reduce the turbidity or the dirtiness to be able to clarify the water. And it needs to be used in the same process. So if you think about chiller water, for example, in XYZ application in poultry, scalder water, heating tanks for some process where you need to heat an item for whatever purpose that might be. By being able to recirculate this water through our generator, we can make that water last essentially for infinity. We actually, as part of our process in cheese brine, we're working with some facilities that have cheese brine that's 23 years old, microbially completely benign. We don't see any infiltration of microbes or funguses or molds. Again, we're into microbial elimination. We're a food safety company. So much of the world is so dependent on chemicals because it's so established, and really it has been the norm forever that chemicals are used in the food processing or the food generation process. Parasitic acid, ammonia, bleach, hypochlorite, sodium hypochlorite, our evil twin brother. There is simply the most used sanitizer in the food industry. And I guarantee you, almost all of you probably have a bottle of it somewhere in your laundry room. So this is really kind of the bones of what we do. So I'm going to give you a little lesson in chemistry in chlorine. Everybody thinks they know what chlorine is. We all know it when we smell it. We don't want to taste it. We can feel it. We know what it feels like. Though it's the most used sanitizer in the world, sodium hypochlorite on its own has no disinfection capabilities. So if you never read the bottle of bleach that you have in your laundry room, you would never read that you're supposed to use a capful in like 4 gallons of water. Why is that? It's because when they send you bleach, or when you buy bleach, if you look on the far right, that's where your hypochlorite is, your chlorine species. If you go down to, say, 10 pH, that red line, that's the disinfecting capability. That's hypochlorous acid, which is what we produce in our process at BIOIONIX. When you add a little bit of water to your cupful, you maybe get it to 8.5 pH, which you're getting a fairly good amount compared to what you had. You got about 5% if you look at the very bottom corner of that graph. If we're able to, by adding a small amount of lactic acid, if we're able to raise that pH into the 5 range, all of a sudden we're making the top of that curve, that red curve, we're making all hypochlorous acid. And people are saying, well, I've never heard of hypochlorous acid. Well, you should have. It's in all of our bodies. It's been around since mammillary life. None of us would have made it through infancy without hypochlorous acid. Our body, through a process called myeloperoxidase, is able to produce this. It is the killing component of a neutrophil. So go back to 8th grade, freshman, high school science, the concept of phagocytosis. You know, you've got a pathogen, microbe, and this big neutrophil comes and swallows it up, pokes holes in it. It's poking holes in it. It's poking holes in it with hypochlorous acid. So it speaks to the safety of this form of chlorine. By the way, it also doesn't gas. It doesn't taste. It's fully consumable, and it's non-corrosive. So this is how it actually is able to do it. The red is the hypochlorous acid. The blue is your hypochlorite. So that's a negatively charged ion. The outside of a cell wall has a negative charge to it. So from an ion standpoint, if you think about magnetism or reverse magnetism, you've got a negative ion hitting a negative cell wall, that's going to bounce off. Hypochlorous acid, because of its neutrality, is able to penetrate that cell wall and get complete and full elimination of that pathogen. So hypochlorous acid has no known microbial resistance. It is agnostic for gram positives and gram negatives. We've got some data that will prove that. And again, it's all natural. We're here because of it. It's what you're trying to squeeze out of your bottle of bleach to be able to get some sanitation with it. I mentioned its non-corrosiveness, sodium hypochlorite, as you see next to the picture. This is 3 days of mild steel bolts placed in these different common chemicals used in the food industry. Simply remarkable, the difference between sodium hypochlorite and BIOIONIX's bolt here, and that's because of our platform of hypochlorous acid. The peracetic acid, very commonly used sanitizer in the food world. That bolt actually got brittle to the point that it started to almost break apart. So this is our system. To put it in perspective, about as tall as me, about as 3 times as wide as me, depending on if it's before or after Thanksgiving. But it's a relatively small unit. This unit, to be able to kind of walk through how the process goes, down where the number 1 is on the bottom, that's the inlet into the system. So we take water or brine, either with a lot of salt in it or a very small amount of salt in it. We'll pass that through, if you look at the middle or the back of it, those anodes and cathodes. So it's an anode and a cathode relationship, and that creates a flow of electricity that we push through that as we monitor that water when it comes through. As that moves out, it then goes out into the process as a disinfected liquid, water, that also serves as a vehicle of disinfectant, because the byproduct of this hypochlorous acid that we produce, the chlorine we produce, is a highly effective disinfectant that's safe for food, materials, and people. On the right is one of the other beautiful things that we have in our technology, is the ability to give real live 24/7 monitoring of the process. So some of our producers, we're able to show them how many thousands of gallons of water they're saving in a day, what their chemical costs savings per day are by using our technology. We also have the ability to make sure that it is operating fully and completely. And this is a phenomenal tool that we're able to provide. So we're not in the business of just selling a machine, we're also in the business of being able to become part of the process. So we just did some studies. We're really kind of breaking into this sanitizer replacement. So if you think about processes that are using already used salt water, well, we said, well, what if we just we actually did a study with University of Wisconsin where we inoculated basically 50 gallons of clean water at an ORP level of 600. That's our internal jargon. We were able to add Listeria at about 10 log into that and completely eliminate it in 2 seconds. So I looked at Ryan, our CEO, who's in the front row, and I said, we need to start making sanitizer. We need to be able to replace sanitizer in CIP processes because we've got something here. The concept of being able to take your tap water, add some salt, a small amount of acid, lactic acid, and be able to replace your chemicals, your sanitizers you have in your facility, I'm like, I think people might buy that. I know I would. So we did a very simple 30-second spray test. This was just to get us on the target to see what we could produce. So we took stainless steel coupons, epoxy coupons, and plastic coupons. We had them inoculated with Salmonella, El Mono, E. coli, and Bacillus cereus. And we were able to produce, generally speaking, an average of 4 to 5 log reduction on these surfaces with a 30-second spray. Now, In a CIP process, you're looking at a lot more exposure time than 30 seconds. We would expect to see all those numbers maxed out. But we were really pleased with that. And as I had mentioned, agnostic towards gram-positive, gram-negatives. As you know, L. mono and Bacillus are gram-positives. E. coli, Salmonella are gram-negatives. Very good results. And we expect to see even some better results in the future. So we need to be able to reduce turbidity to reuse water. It's just one of the things that we need to do. So I mentioned, aside from the ability to be able to produce an end product, this hypochlorous acid, this highly desirable form of chlorine, we have the ability to change some of the physical characteristics of the water itself. And this is, I think, personally, I get most excited about this. There's three phenomenons that occur when you put water, you pass electricity through water. Total or partially dissolved solids in that water will take on some unique physical changes. Essentially, you start rearranging ions on these particles, and they experience a phenomenon called electrocoagulation. So electrocoagulation has been studied in the wastewater world for quite a long time. And essentially, in that process, you take an anode that is meant to be destroyed, essentially, and you run water through it. It globs these things together, and then all of a sudden, your particulates in the water are then removable. Well, that's exactly what we do in the brining process in cheese plants. So we started kind of playing around with some other, shall I say, less desirable effluents. Evisceration room water from a poultry facility that sat outside for 8 days in the Wisconsin sun this past June. We were able to reduce 6 log of pathogen, essentially remove all of the, and this is the foulest smelling effluent I've ever smelled, and I'm a farm kid. So I've smelled some bad things. This was on the next level. And the amount of solids that we were able to remove from that was absolutely amazing. And we reduced 70% turbidity in that. We can reduce turbidity by up to like 95% in some effluents. So essentially with this electrocoagulation, these particles, they basically combine and make themselves larger. So from a chemical standpoint, H2O and sodium chloride, as we run the electricity through that, they split apart. So you've got loose hydrogen and oxygen molecules that are forming H2 and O2, and they're causing another phenomenon to occur, which is called electroflotation. So these particles that have congealed or combined to become a larger material, they get a buoyancy to them. And that flotation causes the last portion, which is called electroflocculation. So at the top, we get a flock channel. So when we run water through a system, you look at it from the top and you go, you didn't do anything to it. But there'll be a 2-inch layer of this foam particulate on top that you can't see through. If you part that, you'll be able to see through this water. It'll be totally clear. What you can then do with these larger coagulated particles or this foam is you're able to filter them out. So all of a sudden, you can take some coarse filtration, which doesn't affect your throughput rate like microfiltration or ultrafiltration, which would essentially plug from these particles. We can take a larger sieve and be able to remove these particulates, and you could reuse that water. It's what we're doing in the meat industry, in the RTE meats world. It's what we do in the cheese world. And frankly, we're doing some pretty exciting things in the world of poultry with this. Phenomenal technology. So I want to leave a little bit of time for some questions if you have any. Again, this circle of things that we're able to do. You'll see our team around. Leah's in the back. She's our marketing director. Ryan is our CEO, he's in the front. You'll see they've got the Path to Zero shirts on. This Path to Zero campaign that we're on is explaining and showing to people that you can eliminate chemicals in your process by using this technology. You can completely change your effluent that leaves a facility. You can save tons of money in wastewater management that way. You can save tons of money by chemical elimination, by being able to take tap water, add a small amount of salt into it, and run it through our generator. I think that's it. Questions? Please.
Do you need any different equipment in order to do this?
No, essentially what we have is our generator, which has the ability to handle our largest system in Chile, does 8 million gallons of seawater a day in the salmon industry. We need a pump to be able to pump that water into our system and through our system. The only thing, if you had a closed loop system where you just wanted to make a volume of sanitizer, you would need a tank. Essentially, you would need a tank to be able to hold that and for us to be able to recirculate it. Now, the reason you can't go into a store and buy a bottle of hypochlorous acid, you can go, and I encourage somebody to do it. If you go to Amazon right now and you put hypochlorous acid, you're gonna see some different types of like eye washes that are fantastic. They use this as a wound irrigant in World War I. So it's old technology. But how stable that is I really have a tendency to question it. This needs to be produced on site. And it needs to be used readily. The nice thing is it reverts back to its original form, which is water and a little bit of salt. You can run that back through our system, and it'll get all of its disinfection capabilities back, and it won't damage your wastewater stream from that standpoint. Question?
So your flock tank, so we make a lot of refrigerated soup. We use water chillers, but you get the odd cup that spills or whatever, and over time the water gets greasy. And is your flocculation system that's pre-treatment before it hits the hypochlorous acid?
It can. So one of the interesting things is some of the best flock we produce is fats, oils, and greases. And so we're in a process right now that has, we were really concerned about being able to manage this grease in a process. Fortunately, that we found these things that are called polypropylene buoys that won't absorb water, but they absorb grease. We're able to completely clean that water up. Organic loading of a water will dictate the amount of free available chlorine we can produce. So one of the things we don't overcome, which hypochlorite doesn't overcome, is occupation of free available chlorine. Where we can overcome it is by being able to continually reproduce it without having to dump in additional bottles of bleach to just get occupied by heavy organics. We're able to actually take that water and disinfect it and then put small amounts of chlorine back into it. Good chlorine, the kind of chlorine you want, that you can't buy. Questions? Did I answer your question about things that you would need? Really, it's a pump, a tank. The beautiful thing about us is we're a very custom solutions company. All of our systems are pretty unique. We find different ways of doing different things. I see somebody in the room that approached us at a show once and asked us if we could do something, and we're pretty close to doing some pretty amazing things that haven't been able to be done before. That person's also seen this at a very high dose, and what I'm sure would be able to comment on the lack of chlorine smell. It's quite remarkable. Yep. Go ahead. Yep. Yeah, we replace chlorine dioxide processes. We have a lot of people call us about ozone, chlorine dioxide, pasteurizers, UV. We treat a ton of, we replace a lot of UV systems. UV is a really cool technology as long as you've got a perfectly clear liquid. But as soon as you have some turbidity and you can't get that UV light to penetrate through that water, you've got accumulation of disinfection. That's a beautiful thing about our process. We will set the system up where we can do a 500,000 gallon brine lagoon. We can get the throughput through our system to be able to send all of that water through our generator, hit it with hydroxyl ions and other reactive oxygen species in that, and still produce a small amount of hypochlorous acid to go in. That's how we're able to overcome these issues, and we're able to give a level of disinfection that you can't get with other vehicles or other technologies.
Have you done any applications where it is used to disinfect packaging before it's filled?
Yeah, in fact, indirectly we do that a lot in a lot of ability. We have a lot of abilities to do that, for sure. But so, yeah. Any other questions? Sanitizer replacement? Good. Yes.
What about degreasers?
Degreasers? So that's an interesting topic. I think I'm going to have an answer for you in about a week. I mentioned this process that we've seen. We have some grease. I'll just say this. The grease that we saw in this process prior to us intervening had a totally different profile to it. I believe that most of that grease that's in that will be eliminated. If you think about the chemistry of what we're doing with a water molecule and sodium chloride, so like I mentioned, that's getting split up into different components. We can recombine the hydrogen and the oxygen in single atom with the chlorine to make HCl. There's sodium hydroxide that is also made in that, which is an incredibly effective sanitizer or degreaser. I mean, it's soap. With that, we see cleaning occur because we are making a small amount of that, but the fact that we're constantly in these processes doing that, and there is data, and I actually did look up, and there is some good data that shows that what we make is what, if you want to look it up from a research standpoint, look up electrolyzed water. More specifically, in our case, look at neutral electrolyzed water or slightly acidic electrolyzed water. If you recall from that curve I had shown, we fall somewhere in that 7 to 5 pH range. You'll find that there's proof that it works as a degreaser, electrolyzed water, neutral electrolyzed water. You'll find that it also works as a descaler. Anecdotally, we're working with some folks on doing a single-pass CIP. Penn State University did a fascinating study where they did a single-pass CIP compared to commercial single-pass CIPs in the dairy world. My biggest concern was, what are you going to do with those fats that are residing in that milk fat, in those lines and in these tanks, elbows, gaskets? The bioluminescence studies they did on that showed none, zero. So it was that to me was the challenging part of a single-pass CIP with that technology, and that was completely addressed. That the bioluminescence showed there wasn't any fats left on that surface. Its reduction of surface tension is one of the things that it does. If you go ahead. I'm sorry? You didn't recover the water on the single pass. They didn't. Penn State didn't. We could do that. You can't do it in dairy, though, because you need to have a fully potable water rinse to make PMO. But in other processes, yeah, we're looking at doing a closed-loop CIP where we could capture that water, recapture it, run it through our generator again, reproduce the amount of hypochlorous acid that we would want. In the sanitizer and CIP replacement, we're looking at pretty high parts per million, 150 parts per million. In our food processes, Some of them we're fully disinfecting with parts per million in the 1 or under range. Hypochlorous acid is that effective of a killer. It is that good of a species of chlorine, especially compared to hypochlorite, 100 times more effective. I'm out of time in 24 seconds. We're in booth 1, so as you come into the room, we're down and towards that way. Please stop and see us. We'd love to answer any questions. If there's water used in your process, anywhere in your facilities, in your process, I would bet there is one way that we would be able to increase your sustainability, reduce your cost in chemical, and give you a very favorable product. So come and see us. Thank you.